Hello LabTurtles. In this video, let us talk about endothermic reaction, which is another type of reaction in which energy change takes place. So endothermic reaction is kind of the opposite of an exothermic reaction. In endothermic reaction, heat energy is absorbed. So that means that if such reactions have to occur, they need heat energy. The reactants are going to gain this heat energy and then they are going to form products. So let's see the first example now. Limestone is being heated to give quicklime and carbon dioxide. So what is limestone? Limestone or chalk or marble is just calcium carbonate. It is calcium carbonate. So let us write the formula of calcium carbonate. So calcium ion is Ca2 plus and carbonate ion is CO3 2 minus. So this 2 and 2 get cancelled out and we get calcium carbonate as CaCO3. Quicklime is calcium oxide, which is CaO. So now the reaction says that limestone is heated strongly. So CaCO3 and this is being heated. So I am drawing the symbol of heat on the arrow and it gives quicklime, which is calcium oxide and carbon dioxide gas. And let us write the states now. Calcium carbonate is solid, calcium oxide is again solid, carbon dioxide is gas. So we'll try to balance it now. On the left hand side or the reactant side, number of calcium atoms is 1, same as on the right hand side. Then number of carbon atoms is 1 here and on the reactant side also it's 1. And what about oxygen? On this side we have 3 oxygen atoms, whereas on the product side we have again 3 oxygen atoms. So the atoms of different elements are equal on all sides. That means that this reaction is balanced already. So let's move on to another example now. So in example 2, green vitriol crystals are being heated and we get ferric oxide, sulfur dioxide, sulfur trioxide and water. So let us try to write the reaction here. Green vitriol is FeSO4.7H2O. So FeSO4.7H2O and when it is heated, we get ferric oxide. Ferric ion is Fe3 plus, oxide ion is O2 minus. So ferric oxide will be, this 2 comes here, this 3 comes over here. Ferric oxide should be Fe2O3. So we get ferric oxide plus sulfur dioxide, which is SO2 because it's dioxide. Similarly, sulfur trioxide will be SO3 and we also get some water. So H2O. Let's try to balance this equation. The first step would be to write the states. So these are crystals, solid. This is again a powder, which is solid. And both of these are gases and water would be liquid. There are also some major color changes in this reaction that we need to remember. So green vitriol, as the name suggests, it would be green in color. Ferric oxide is reddish brown in color. This is reddish brown. Both these gases are colorless. Now we move on to the balancing part. So over here, number of iron atoms are 1 on the left side and on the reactant side there are 2 iron atoms. Then sulfur, over here it's just a single sulfur atom, and on the right side we have two sulfur atoms. Oxygen, what we'll do is that when we are trying to balance this equation, we are going to consider this H2O on the whole. So when I'm counting oxygen, I'm only talking about the oxygen which are present in ferrous sulfate or FeSO4. So here there are 4 oxygen atoms, and on this side 3, 4, 5, 6, 7, 8. There are 8 oxygen atoms. And let's write water separately. So this side we have 7 water molecules, and on the side of the products we have only 1 water molecule. So let's try to balance it out now. So as we can see, iron is 1 atom here, here it's 2 atoms. So let's try 2 over here. Now number of iron atoms has become 2 on the left hand side. Number of sulfur atoms has also become 2 now. Number of oxygen atoms is 4 multiplied by 2, which is 8. And the number of water molecules, it's 7 multiplied by 2, which is 14. So everything is balanced now except these water molecules. So we need 14 water molecules on the right hand side as well. I can just write 14 over here. So this becomes 14. The reaction is balanced now. Remember, this is very important for board exams. So pay good attention to this equation. One more important observation in this reaction is that SO2 gas has smell of burning sulfur. Smell of burning sulfur. So we get this peculiar smell when this reaction takes place. Let's move on to the third example now. In the third example, lead nitrate is being heated to form lead oxide, nitrogen dioxide and oxygen gas. So again we are using heat for the reaction, which suggests that it is again going to be an endothermic reaction. Let's try to write the equation now. So first of all, we'll write the formula of lead nitrate. So lead is 2. So Pb2 plus, nitrate is NO3 minus. So what is the formula of lead nitrate? 2 comes here, this minus 1 comes here. We get PbNO3 whole twice. And let us also write the formula of lead 2 oxide. So that would be, this is lead ion and this is oxide ion. Lead 2 oxide is just PbO. 2 and 2 get cancelled. So the reaction would look something like this. We take some lead nitrate, PbNO3 whole twice, and we are heating it to form lead oxide plus nitrogen dioxide. So again NO2, because di means 2, and we are getting oxygen gas. I would suggest that you again look at this equation carefully because it's a frequent exam question. So this is a white powder. This is white in color. Lead oxide is yellow in color. NO2 is a gas and it is a brownish gas. So this is a brownish gas. Oxygen is colorless. As we all know, it's present everywhere around us and we cannot see it. This is what we breathe in. Oxygen is colorless. And we'll write the states now. So lead nitrate is a powder which is solid. Lead oxide is again a yellow powder, solid. NO2 is a brownish gas. So G. Oxygen is gas. And now the next, to balance this chemical equation. Let us write the number of atoms of different elements on each side. So lead is Pb, only one atom on this side, only one atom on the side of the products. Then comes nitrogen. So here there are two atoms of nitrogen, and on this side there is a single atom of nitrogen. And oxygen, this side it is 3 into 2, which is 6 atoms. This side it is 1, 2, 3, 4, 5. So total of 5 oxygen atoms. So what is not balanced here? Nitrogen is not balanced, oxygen is not balanced. So let us first try to balance this nitrogen. Nitrogen is 2 on the left hand side. So on the right hand side also we make it 2. So we have 2 NO2 now. So nitrogen has become 2 on this side. Oxygen has become 2 2s are 4. 4 plus 2 is 6 plus 1, which is 7. So it's not balanced. Oxygen needs to be balanced. This side it's 6, this side it's 7. What can we do in such a situation? How about we write a 2 over here. So now oxygen on this side has become 8 and lead has become 2. So we try to balance lead on the reactant side as well. For that we'll write a 2 over here. So now lead has become 2 on the left hand side. Nitrogen has become 2 into 2, which is 4. Oxygen has become 3 into 2, 6. 6 into 2 is 12. So again we see that nitrogen is imbalanced. So this side we need 4 nitrogen. Instead of this 2, how about we write 4 over here. Now on the right hand side we have 4 nitrogen atoms and 4 2s are 8, 9, 10, 11, 12. 12 oxygen atoms. So this equation is balanced now. We'll see different types of reactions in the next videos.